Now this is a panel for three-phase induction motor controller with IGBT inverter V/F drive. So you can see this is again a polycarbonate printed panel with all the diagrams and all the labels printed on it. Digital voltmeter and digital ammeter. Again we are providing overcurrent warning indication. This is a digital speed indicator for the motor. Then you can see there are various controls on the panel. This is a speed control panel, speed control potentiometer. Then this is a clockwise, anti-clockwise direction control switch. This is a main start and stop switch. Then this is a main V/F drive, VFD drive. This is an industrial VFD drive. Basically the panel is that we are converting this industrial VFD drive into an educational kit. Inside the panel we have provided again isolating transformer for CRO. The CRO should be connected on this side. The mains of the CRO should be connected this side for observing the waveforms. Then this side the probes of the CRO should be connected. So the main precaution is that while using CRO, always mains of the CRO should be always connected to the output of the isolating transformer. Now we can see these are the connections for the motor. This is a connection for the motor, 12 pin good quality Johnson socket. The motor is connected in a delta connection. This is a connector for speed indicator, or this is a connector for proximity switch. So now we'll come to the motor. This is the motor, three-phase induction motor, 220 volts, three-phase induction motor. And this is a loading arrangement. A sturdy loading arrangement is provided. This is the way you can load the motor. Also a proximity switch is connected. This is a proximity switch for the measurement of the speed. Now basically the aim of our experiment is, first thing is we should calculate a V/F ratio, voltage versus frequency ratio. The frequency can be seen here and the voltage can be seen here. So we can calculate the V/F ratio. Then we can observe the overcurrent cutoff operation. You can see the clockwise and anti-clockwise rotation. Then you can calculate speed versus torque characteristics. So here you are going to see the speed of the motor, and for calculating the torque we will be providing a spring balance to this system, T1 minus T2 spring balance type of loading arrangement. Right now in the given setup it is not provided, but for particularly for polytechnics we will be providing a spring balances in the series of this particular belt. So manually you will be able to calculate a torque here, T1 minus T2 type of calculations, and you can see the speed here. Also inside the drive there is a provision to calculate the torque directly. That is a direct method of calculating the torque, which is inbuilt function of this VFD drive. So all your experiments will be performed as per your MSBT manual. So now let us just press this start button. So the motor will start running, and you can see the speed of the motor here. Speed of the motor, this is the output voltage, this is the input current, this is the frequency. So this is the way you calculate a V/F ratio. This is the frequency and this is the voltage. You can see the motor running. The proximity is giving up 1 pulse per revolution, and I am calculating the speed. On this side you can connect the CRO. Thank you.